Okay, this is the Unit 11 review. So the first question says, what is the mean and standard deviation of the measures -4, -3, 0, 8, 9, 2, 6, and 1? So what we're going to do is we need to put that into the calculator. And we're going to put it into Stat Edit. And then we're going to enter those values into List 1. Always make sure that you double check that you have all the values correct. Okay, and then it wants the standard deviation and the mean. So we're going to do stat calc. We're doing one variable statistics. Calculate. So the mean is the X bar here, which is 2.375. And then the standard deviation, which is right here, our standard deviation is 4.55. It says, what is the z-score for x sub I equals 0 for the given data set? Okay, so on your formula sheet, you know that z-score equals the data value minus the mean over the standard deviation. So the data point was 0, so my z-score equals 0 minus the mean over the standard deviation. And you can put that whole thing in the calculator. So we're going to do alpha y equals, so 0 minus 2.375 all over 4.55. It gives me negative 0.52. Okay, now let's look at the next one. Same question, except we have different data values. So put that into your list in the calculator and then calculate the z-score. All right, we put our data values in. Stat calc, one variable statistic. The mean is 14.14. Standard deviation is 6.5. This time the z-score with the data value of 16. So 16 minus 14.14 over 6.5. Put that all in the calculator. Alpha y equals 16 minus 14.14 over 6.5. Enter. So a z-score of 0.29 if we're rounding to the nearest second decimal place. Okay, let's look at the next one. The nationwide exam, the Adams School has a mean of 875 and a standard deviation of 12. And the Boswell School has a mean score of 255 and the standard deviation of 20. And which school has the greater consistency in scores? Okay, so I'm going to kind of highlight here and summarize some of this data. So I have Adams School has a mean score of 875 and a standard deviation of 12. Okay, so I have Adams. The mean is 875, standard deviation is 12, and then I have the Boswell School, mean of 855, and a standard deviation of 20. Is 855 and a standard deviation of 20. And then it says, which school has the greater consistency? Well, you should know that what standard deviation, the standard deviation of 12, okay, means that the data values are closer together. With a larger standard deviation, it's further apart. Okay, well, if your data points are more closely linked together around the mean, that means that the Adams School has greater consistency. Because their scores are not widely spread out. Okay. All right, let's let's look at the next one. It says, on the standardized test, Phyllis scored 84, exactly one standard deviation above the mean. If the standard deviation for the test was 6, what is the mean score of the test? Okay, so this one, again, these are really good ones to highlight. I have Phyllis's score, okay, is one standard deviation above the mean, and the standard deviation of 6. So if you want to think about our normal curve, okay, so we know that the mean is somewhere here, which we don't know, and we know that Phyllis is exactly one standard deviation above the mean, and her score was 84. And it says that the standard deviation was 6. So this space here, standard deviation was 6, which means in order to get back down to the mean, I would do 84 minus 6, and that gives me 78. So the mean would be 78. Okay, next one, in a normal distribution, approximately 68% of the scores fall between 72 and 86. What's the standard deviation? Okay, so we're back to our normal curve. All right, so this one we don't know what the mean is, but it says 68% of the data. Well, if you remember, 68% of the data falls between one standard deviation below and one standard deviation above the mean. This is 68% of the data. Well, it says the scores were 72 to 86. Okay, and it wants to know what the standard deviation is. Well, to find the standard deviation, we're going to do 86 minus 72. Okay, and I have two standard deviations here, one below, one above. So alpha y equals 86 minus 72 divided by 2 gives me 7. So I have a standard deviation of 7. And check to see if it works. 72 plus 7 will take you to the mean, that's 79. Well, plus 7 more better be 86, which it is. So we've done it correctly. Okay. All right, next one. On a standardized test, the scores are normally distributed. The mean is 68 and the standard deviation is 4.5. What is the best approximation of the percentage of scores that will fall between 59 and 77? Okay. Well, you could do this two ways. I'll show you the way with the graph first. So we have normal distribution. That was ugly. I have a mean at 68. And then I know that if I go out one standard below and one above, that represents 68% of my data. Okay, but it's looking for between 59 and 77 what the percentage is. So in order to find the range here, I'm going to have to subtract 68 minus my standard deviation of 4.2. That's going to give me one below. So one below is 63.5. And I'm looking for 59 and 77. And 68 plus 4.5 is going to be 72.5. Okay, so I'm going to go another standard deviation out. So I'm going to go 2 standard deviations up. And remember, when you go one more standard deviation, you're going 13.6 on both sides, which means that we are .95%. That's 95% of the data, but remember, we've got to look at that range. We want 59 to 77. So, oops, I didn't go out far enough. Sorry about that. This one's 13.6. Okay, so we've got one more standard deviation, 72.5 plus 4.5 gives me 77. Well, there's the top part of my range right there, 77. And then we have 63.5 minus 4.5. Gives me 59. And that's the lower part, which means that 95% of my data, okay, the area under the curve, 95% of my data is between 59 and 75. All right, let's look at the next one. Okay, the mean of the normal distribution set of data is 56. The standard deviation is 5. So mean is 56. Standard deviation is 5 according to the empirical rule, in which interval do approximately 95.4% of all cases lie. So this is kind of like the opposite of the one we just did. All right, so I've got normally distributed. It says my mean is at 56. I'm going to go up a standard deviation. And I'm going to go up 2 standard deviations. And then, because I'm looking for 95.4%. So 95.4% you should know is between 2 standard deviations below the mean and 2 standard deviations above the mean. So then I'm going to go down 1, down 2. And this represents 95.4% of the data. But I got to figure out what that is. What are those scores? What's this score right here that's 2 below and 2 above? Well, in order to find out what those scores are, we're going to take our mean and we're going to add the standard deviation. 56 plus 5. That gives me 1 standard deviation up. Plus 5 again. That's going to give me 1 more. So that's 2 above. So 66 is 2 above. And then now I need to go the other way. 56 minus 5. It's going to give me 51. That's 1 below, but I need to go 2 below, which is 46. So 95.4% of the data lies between 46 and 66. All right, let's look at the next question, next page. "20 high school students took an examination and received the following scores. Determine what percentage of the students scored within 1 standard deviation of the mean. Do the results of the examination approximate a normal distribution?" Okay. All right, so the first thing you're going to need to find out is what the mean is and what a standard deviation looks like. So in order to do that, we know we've got to go into Stat, Edit, and we're going to put in all your data points in here. All right, once I've put my data in there, we're going to go to Stat, Calc, 1 variable statistics. All right, so I know that my mean is 79.1. And it says that I want scores within 1 standard deviation of the mean. So within 1 standard deviation of the mean would be 1 below and 1 above. So 1 below, okay, I'm going to subtract my standard deviation of 8.7. So my mean 79.7 and my standard deviation was 8.71. Okay, so 79.7 minus 8.71. So 1 below would be 70.99. And then 1 above, I'm going to add my standard deviation, would be 87.81. So between 70.99 and 87.81, okay, would be within 1 standard deviation of the mean. So it says, do the results of the examination approximate a normal distribution. So what you're going to have to do is you've got to figure out what percentage of the scores fall in this range. So does 70 fall within that range? No, that's below. Does 60? No. 75? Yes, 75 falls between this range. 68? No. 85? Yes. 86? Yes. 78? Yes. 72? 82, 88. All I'm doing is saying, does 88 fall between 70.99 and 87.89? And actually 88 doesn't fall between there, does it? Right, because 88 is going to be a little above that. Okay, I actually wrote that down wrong. So if I take my mean 79.7 plus 8.71, which is one standard deviation, is 88.41. 88.41. All right, so I lied to you. 88 does fall in there. So 88 works. So we've got another 88 to 73, yes. 74, yes. 79, yes. 86, yes. 82, 90, 92, 93, no. 73 does. Okay? All right. So now, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 scores. So 14 of the scores fall between one standard deviation around the mean. Okay, but I want to know, how does that compare? Remember that the empirical rule says if it's a normal distribution, then it's 68% of the data should fall between 1%. I'm sorry, one standard deviation about the mean. So this has 14 scores. Well, to find the percentage of those 14 scores, we would divide that by the total. And there's 20 total. So to find the percentage of data that falls between one standard deviation, it's 70%. So that's pretty close to normal distribution. So based on our calculation, it's 70% of the data, but if it's a normal distribution, it has to be 68% of the data. So it's pretty close. I would say yes, it is in this one. Okay, let's look at the next one. Ramirez is a real estate broker. Last month, the sales price of homes in her area approximated a normal distribution with a mean of $150,000. Mean of $150,000 and a standard deviation of $25,000. The house had a sales price of $175,000. Ms. Ramirez told the customer that most of the houses sold last month had selling prices between $125,000 and $175,000. Explain if she is correct. Okay, so remember what the word most means, and we know that we have a mean of 150. So what I would do is, you're not sure how to solve a problem, I would go ahead and draw out the normal curve. Okay, because it says that it's approximate normal distribution. So I have 150,000 is my mean. Okay, standard deviation is 25,000. So let's just go one out. So 50,000, 150 plus 25,000 gives me 175. And then below 150 minus 25 is 125. Okay, so she said that the houses sold, most of the houses were between 125 and 175. Well, remember that between one standard deviation below and above represents 68%. So I would consider that most of the houses. So yes, she is correct. Okay, because the range of the home sales is one standard deviation below and one standard deviation above. All right. Let's look at the next one. The mean score of a normally distributed exam is 42. Standard deviation is 12.1. What score would be expected to occur less than 5% of the time? All right. So, got our normal curve. We said this is, mean was 42. Remember, if you go out 1 standard deviation, 2 standard deviations, okay? So this represents 95.4%. So anything outside of that is going to represent less than 5%. So less than 5% is this area out here on this side. Okay, less than 5% is that area out there. So let's see. Well, I know that that's 2 standard deviations out. So let's do 42 minus 12.1. That's 29.9. Minus again. Minus 12.1. So that's 17.8. Okay, so anything below 17.8, and then 42 plus the 12.1 gives me 54.1. And then we're going to add it again because I want to go one more standard deviation, 66.2. So anything above 66.2 would also occur less than 5% of the time. Okay, so if we look here, the only one that's above 66 would be D, 67. Okay, let's look at the next one. It takes Jose an average of 2.5 hours every evening to complete his homework for all of his classes. Okay, so that's average. The homework for all of his, if the standard deviation is 0.7 hours and the data is normally distributed, what is the probability that his homework will take between 2 and 3 hours on the evening of his birthday next Tuesday? Okay, so normal distribution. So the other way that we could do this is to use the calculator. All right, so it says that I have an average of 2.8, I have a standard deviation of 0.7, and they want to know between 2 and 3 hours. Okay. Now the only way the normal distribution works when we're finding these percentages like we've been doing before is if it's exactly 1 standard deviation or 2 standard deviations. It has to be a whole standard deviation, but in this case it's not going to be because it wants to know between 2 and 3. Okay. So the calculator will tell us when it's not an even standard deviation. So you're going to do second vars. So you probably want to write this down. Second vars. And then we're doing number 2, which is normal CDF. So number 2. All right, so the lower bound is 2 because I want to know between 2 and 3. My mean is 2.8. My standard deviation is 0.7. And once you get to the screen, you're going to press enter one more time. So 0.486. Okay, or as a percentage, that's about, if I'm going to round, 49%. So there's a probability of 49% that his homework will take between 2 and 3 hours. All right, let's look at the next one. It says the height of 1,000 students at a local school were recorded and found to be approximated by the normal curve below. What would represent the mean and standard deviation of this data? Okay, well, you know the mean is right here in the middle, so the mean is 63. Okay, and remember that the distance between the mean and 1 standard deviation, okay, so that distance there is going to be your actual, the number of your standard deviation, so you can just do 67 minus 63, which should be 4. So the standard deviation is 4. Okay, next one. Compare the quantity in column A with the quantity in column B. Okay, so column A, we've got a mean of 15, standard deviation of 4.3. The value is 3 standard deviations above the mean. Okay, and then we have standard deviation of 35. I'm sorry, mean of 35, standard deviation of 2.9, and then our data point is 2 standard deviations below the mean. Okay, So the question is, compare the quantities and say which one is correct. The quantity in column A is greater. The quantity in column B is greater. The quantities are equal, okay, and the relationship could not be determined. All right, so if we know that the mean is 15, it says 3 standard deviation above the mean, okay, which means I'm going to add 3 standard deviations. So 15 plus 4.3 plus 4.3 plus 4.3, because it's 3 standard deviations. 15 plus 4.3 plus 4.3 plus 4.3. So that gives me 27.9. Okay, so this data point is 27.9. All right, and then this one says 2 standard deviations below the mean. So I have my mean at 35, standard deviation of 2.5, so 35 minus, 2.9. It says 2 standard deviations below. So this data point would be 29.2. Okay, so I did 35 minus 2.9 minus 2.9. Okay, so my value there would be 29.2. So, quantity A is greater? Nope, quantity B is greater. So that's the correct answer. All right, let's do one more page. The shoe manufacturer collected data regarding men's shoes and found that the distribution of sizes exactly fits the normal curve. The mean shoe size is 11. The standard deviation is 1.5. What's the probability a man's shoe is greater than 1 standard deviation above the mean? Okay, well, we can use second VARs again. Number 2. 1 standard deviation above the mean. Okay, so we know that for both A and B, we have a mean of 11, a standard deviation of 1.5. So I want to know, and I'm just going to sketch this because this helps me to see it. I want to know 1 standard deviation above the mean. I want to know everything over here. 1 standard deviation and above. All right, so if it's 1 standard deviation above, remember it's going to ask you for your lower. Well, your lowest point is 1 standard deviation. Okay, but 1 standard deviation would be what though? What shoe size is 1 standard deviation? Well, 1 standard deviation would be 11 plus 1. Oops. Plus 1.5. So that would be 12.5. Okay, because the actual standard deviation above will be 12.5. Okay. And then we're going all the way, anything above that, so then my upper is going to be infinity. And then I have my mean and standard deviation. So now we can go into the calculator, second VARs, normal CDF. Remember our lower was 12.5. My upper, remember you can't put negative infinity into the calculator, so you're going to do, negative or positive infinity in calculator. So I'm going to do 999999999. Mean is 11. Standard deviation is 1.2. When you get back to that screen, press enter one more time. So 0.16. All right. What's the probability of the man's shoe size being less than 1.5 standard deviation? Okay. So same thing here. Okay, but this time I want 1.5 standard deviations less than. This is a little more tricky because it wants 1.5 standard deviations. Well, I know a standard deviation is 1.5. Okay, so time. That gets me 2.25. Okay, so, and it says that I want less than below the mean. So I'm looking at 1.5. So I need to know what exactly that shoe size is. Okay, so I'm going to do 11 minus 2.25. So that's 8.75. Okay, and I want to know less than, so I want to know everything over here. Everything over here. So my lower bound is going to be negative infinity. And my upper bound, I'm going to stop here at the 8.75. And then I have my mean and standard deviation. So we're going to go back to, second vars. So normal CDF. So this time I have negative 9999999. Upper bound is 8.75. Mean is 11. Standard deviation is still 1.5. When you get to that screen, press enter one more time. So 0.067. Okay. The International Football Federation ran a test on the air pressure of soccer balls. It was found that the air pressure contained in soccer balls used in the 2010 World Cup games in South Africa was normally distributed and had a mean of 12.7 psi and a standard deviation of 2.3. The regulation states that the air pressure of a soccer ball should be between 8.5 and 15.6. Did 95.4% of the soccer balls tested fall within the regulation air pressure range? Justify your answer with the empirical rule. Okay, so it says it's normally distributed. Okay, and we know that 95.4 is going to be 2 standard deviations below and 2 standard deviations above. So this right here represents, between here and here, represents 95.4%. Okay? So I want to know the ball should be between 8.5 and 15.6. So it tells us that the mean is 12.7. So I want to go 12.7. Remember, standard deviation is 2.3. So plus 2.3 is 15. Plus 2.3 is 17.3. Okay, and then we're going to go down because we're going to do 2. So we've got 12.7 minus 2.3 is 10.4. And then minus 2.3 again, which is 8.1. Okay. So it says 8.5, so 8.5 is somewhere here, and 15.6, which is somewhere here. So I'm missing this big chunk right here to reach that 95%. I'm missing this big chunk, and I'm missing this chunk over here. So the answer is no, they didn't fall. 95.4% of the soccer balls tested did not fall within regulation. The other way you could do this is to put it into the calculator in the second vars. So your lower, to get the exact percentage that it fell, so the lower would have been 8.5, your upper would be 15.6, okay, and then you have your mean, which is 12.7, standard deviation, which is 2.3. So we can put that in the calculator as well. Vars, second vars, normal CDF. So 8.5, 15.6, 12.7, 2.3. So that's 86% of the balls fell within the regulation. But drawing it graphically shows you as well that they did not get the 95%. All right, let's look at the next one. It says the student's scores on a standardized test with a normal distribution have a mean of 500, standard deviation of 40. How many of the 786 students that took the test should score between 423 and 560? Okay, so between 423 and 560, I have the mean of 500 and a standard deviation of 40. So this is the lower bound, upper bound. Okay, so second bars, 423, 560, 500, 40. All right, so that is 90.6, so 0.906. But they wanted to know how many students. So you're going to do the probability, which is 0.906, times the number of students. So times the number of students, which was 7. So that's 714 students, because you can't have half students. So 714 students. And really, whether you're going to use the normal CDF or draw out your normal distribution, it doesn't really matter. You just kind of need to look to see. Remember, if it's a whole standard deviation, then you can use your normal curve and be able to figure out what your percentages are. But for ones that aren't going to be a full standard deviation, then you're going to have to use your normal CDF. All right, let's look at the next one. Okay, it says the height of a group of girls is normally distributed with a mean of 66. If 95% of the height of the girls is between 63 and 69 inches, what is the standard deviation for the group? All right, so this is kind of like the one we did on the previous page. So you kind of want to remember what the curve looks like. Remember 95%, you've got your mean here, which we don't know. 95% is going to be 2 standard deviations below and 2 standard deviations above. So this is 95% here. Okay, and it says that 95% is between 63 and 69 inches. And it wants to know the standard deviation. Well, so if I want to know the standard deviation, I went 1, 2, 3, 4. There's 4 standard deviations. So I want to know the distance between these two. So 69 minus 63. And I'm going to divide that up by 4 because I have 4 standard deviations. 69 minus 63 divided by 4 is 1.5. So I have a standard deviation of 1.5. All right, what is the area of the standard normal curve corresponding to negative 0.58, 2.05? Okay, so if for standard normal curve and they're giving you z-scores, then you can go into normal CDF. My lower bound is negative 0.58. My upper bound is 2.05. When it gives you z-scores, though, your mean is 0, your standard deviation is 1. Enter one more time, so 0.699. Okay? All right, what fraction of the population lies between 18 and 28 if the population is normally distributed and the mean is 23 and the standard deviation is 2.5. Okay, so second, bars, normal CDF, between 18 and 28. This one gives you the mean. It's not in terms of z-scores, 2.5. So 95% of the population. You could have also done that, instead of using a calculator, you could have also done that using the normal distribution curve. Okay, that's it for this video.